Welcome back. We are continuing Chapter 6 on addition, and today we talk about 6C, addition algorithms. We'll cover 4 different algorithms for adding whole numbers together. The partial sums algorithm, the column addition algorithm, the opposite change algorithm, and then our short standard addition algorithm. All right, let's begin. Number 1, the partial sums algorithm. The trick with this is remembering that 634 is really the same as 600 plus 30 plus 4. And 918 is the same as 900 plus 10 plus 8. So we can add these 6 numbers in any way that I want. I could add 600 plus 900, 30 plus 10, 4 plus 8. And so that's what we do with our partial sums algorithm. 600 plus 900, 30 plus 10, 4 plus 8. We find those 3 answers, and then we can add those together. And the answer at the end, 1552. So partial sums algorithm, it takes your number, it breaks it into parts, and it finds the sum of those parts. Okay, number 2. Column addition algorithm. Take the 2 numbers you want to add, 379, 562, spread them out a little bit and make several columns. In this case, I will want 3 columns, and we can label them hundreds, tens, and ones. Then you just add straight down into the 3 columns. Don't do any carrying, but just find out what is the sum of each column. And we find 8, 13, and 11. At this point, now we can start modifying things a little bit. The 11 is really 10 plus 1, so I will carry the 1 over and change my 13 into a 14. Then my 14 is really 10 plus 4. I'll take the 1 over and the 4 will remain. And we end up with an answer of 941. I kind of like the column addition algorithm that we see right away what those 3 numbers are, and we don't have to worry about splitting the number up. Number 3, the opposite change algorithm. There's a neat idea behind this. It's that if I add a little bit to one number and I subtract a little bit from the other number, it won't actually change the problem. Let's say I add 2 to the bottom and I subtract 2 from the top. Then I've created a new addition problem, 362 plus 280. And the answer is going to be exactly the same. And I've simplified that bottom number just a little bit. So now that the bottom number has been simplified, let's continue trying to simplify the bottom number a little bit more. If you wanted to simplify 280, maybe you would add 20 to that. And then if I'm going to add 20 to the bottom, I should subtract 20 from the top number. So we have a new problem. The bottom is simplified now, just 300, and the addition problem is straightforward, 642. The opposite change algorithm is a neat idea. I simplify the problem, simplify the problem, simplify the problem, until eventually the problem is so easy the answer just pops out. Moving on to number 4. The short or standard addition algorithm. This is probably the one that you use and the one you remember from grade school. We just go column by column from the right. 6 plus 7 is 13. So I split the 13 up, carry the 1. 1 plus 5 plus 6 is 12. Carry the 1, write down the 2. 1 plus 4 plus 1 is 6. And there's our solution, 623. The great thing about this short algorithm is that it is short, it is quick, and it is easy. I think some of the other algorithms have advantages, in particular the partial sums. I like partial sums because it lays bare exactly what's going on with addition of these bigger numbers. You really have a sense of the hundreds being added to hundreds and the tens being added to tens to get the final solution. But, of course, this is very straightforward and nice to apply. Some final thoughts on addition algorithms. What's important in all of these algorithms is that likes have to be added to likes. So what do I mean by that? When we're looking at whole numbers, tens have to be added with tens, hundreds had to be added to hundreds, and so on. That same philosophy applies also with decimals. If I'm adding 0.4 and 0.15, then tenths have to be added to tenths, hundredths have to be added to hundredths, and so on. I'm not going to add the 4, which is in the tenths position, with the 5, which is in the hundredths position. And I can apply this idea to fractions as well. 1/4 plus 3/8. I'm not really adding the same thing together. I really need to add eighths together with eighths. This is why we have to convert the 1/4 into 2/8 if I want to do addition. Then now I have 2 of something and 3 of something, and I end up with 5 of that same thing again. 2/8 plus 3/8 equals 5/8. That's all I want to say at this point. Give the worksheet problems a try, give the homework problems a try, and as always, ask me questions if you have them. Okay, take care.